No, don't. So if they don't want to come, don't press them.
Hey, shut up.
Oh yeah, get
Which
him
one for the presentation?
You want to take one each?
You've got a shot. Are they sitting there, or do you need them round here?
Yeah. It's good.
Oh, we're going to be with the camera.
Yeah, please,
Okay.
yeah.
Need a mugshot.
I have yours. I have the set also here.
Basically switch places. Yeah.
That's all right. That's your set.
Put your mouth.
One,
Leaflet Central.
two. And three. You go. Hello, as you might know, I'm Nico, and I'm doing a research and development project about robotics. It also happens that I really like robotics. So this is a sign when you have health and safety first. When you have a robotic, you must have this sign. That's an autonomous device. Robots are here and they are here to stay. Ancient Greeks, they were imagine about robots. And the first robot being imagined by humankind was a robot for defense. So it's from island of Crete was a copper man that was defending the island. What is a robot? A robot is something it's been made. It's human made at the moment. It can be born. It's been created from us. A robot can feel on the environment that it lives, can do stuff, and it has a degree of intelligence. But when we say intelligence, we give the robot this intelligence. It's not born with intelligence. And of course, it can make choices. We can teach a robot what to do, and we can control how it moves. That's imitation of a robotic hand. Robotic hand. That's what we do. We have our friend here has 3 fingers. Total, with the fingers can do 12 moves on its hand. Our hand can do 28 movements. So think you have to program something to do 28 movements. That is a major problem when we try to make artificial limb. We have people that they have serious accidents, so they lose a hand or something else, unfortunately. And in Italy, there is a research laboratory. And they try to find a way to make artificial lumps. So the most difficult part is how to control the lumps. And they use the power of the brain, the same nerves that we use for our movement. The same nerves, they put sensors on some point. Sometimes they just put direct in the brain and they try to make control. So this gentleman, he's trying to control the lump. And if you see, it's quite difficult to control something that is not yours. So he's not supposed to look in the hand, he's supposed to make the same movement. It's not nice too much, but you can have it a better one. That's the movement. That's the only movement he can have at the moment. It's not portable, he can wear it. At the moment technology is not that far, and our problem is how to power the lamp, but that's the idea. This hand, it can compare with our robot, and it has 15 movements, not 28. But it's better than nothing. Other applications. See this fish? It's been created here in the south of UK. They put it in an aquarium. And after a while, the other fishes start interacting with this one. Why they created? This fish has been created. They wanted to explore the reef and make a research. So they create this fish. It's the easiest way. So they won't interrupt the ecosystem, and they have better results when they do the research. Of course, by making a robot like this, you can use it in a military application as well. You can send someone as a spy or as a command to do with explosives. See the movement? Looks natural. Even other fishes inside the aquarium, they were interacting with this one. It's really amazing. By the way, this has been made by students in university. It's not been created in some crazy lab.
What university?
It's, I can't remember, but it's UK in the south. Okay, if you want to say robot, a lot of people think Robo Wars or Star Wars. It's not necessarily like this. A robot needs to be able to do something. You can have robots in cyberspace. You don't need to have a robot with actually a mass. You don't need to touch it. As long as it can take, it's been created from us, and it can take logical decisions and has a certain autonomy, that's a robot. In the past we used to say any electromechanical device with some kind of decision-making mechanism was a robot. That's not the case anymore. Now you can have robots that they decide how to move inside the internet. Viruses, there are some robots as well. I'll take one of them. One of its please. Thanks. So, you have a lot of things robots can do nowadays. That's a Simo. Simo has been made by Honda. Japan is the leading force in robotic making. Here in Europe, or even if you prefer, here in the UK, we can compete them. We can compete the software, the hardware, but we can compete on the software. To create something like this, you need so many engineers design every single little part. Here, we don't have the luxury to do something like this. We can do the software. You only need PC to do the software. Asimo is a humanoid. Like, sorry. And humanoids, a lot of people believe it's the future. Some people not. You don't need humanoid to do a lot of work. You need just a robot to do the job. This lovely lady. She's a robot. And that's a 2-year-old robot. And it's not a professional shooting, it's just someone with his mobile, took his mobile out and asked him. Okay, you can understand that this is artificial. But that was 3 years ago, so think what's going to happen in 5 years' time. There is one company on the internet, and you can actually order a robotic girlfriend. You can have it now, it's pre-ordered, but still it's there. It's going to be here sooner or later. The only problem to have a perfect one, it's power, because you can have, unfortunately, robots consume lots of power. So that's the only problem. Or else we can have almost perfect. I think that would be fair. You know, human girlfriend or a robotic girlfriend, where you have the same thing. When you do this question to IT students, male IT students, usually you have the same answer. When you do to art students, they say no robots. That's not the future. Robots in the past, they used to do the dirty work, the dangerous, the boring job. That's what we used to do. Take a part from here, put it there. Take it apart from here, put it there. 24 hours a day, 365 days a week, every year. Every time. Now, we passed the stage. But still, all these robots, they need someone to program them. To see how important is programming robots like this. On the factory, Jaguar factory, they have, if you go there, you're going to see so many robots in production line. You still have humans, but they have a lot of robots. And the guy who's doing the programming for the robots, he's on 40-something thousand a year. 48,000 a year. He's programming robots whenever they need to do something. These robots that you see here, it's from ABB. When you start working with robots, you're gonna say ABB is one of the big players. They have robots and they can do anything. Simple as that. Their robots can do anything. This is a promotional video of them. You see that we have the satellites. Satellite is a robot by itself. You see the Moon Explorer. What's a robot? If you expect to send a message to the moon coming back, you have about 5 minutes. You can't have 5 minutes decision time. You can't afford that. You must have something instantly. The same with satellites. Those satellites, they need to take a decision instantly. For a lot of reasons. They have to take a decision to close down. If you have a solar storm, you need to shut down. So they need to know how to do it themselves. If they have something approach with speed, they need to close the solar panels. All these are decisions they have to make. Chernobyl. Now they're building a new dome, buried completely. The job is done by robots, just like that. Americans, they have plans. If they have something like Chernobyl, it's going to be robots storming in. It won't be humans the way the Russians done. They go use this, and then you can be close to radiation for a year. No, that was the past. Now it's the future. Robots, it's there. Robots are here, are inside our houses as well. That's a lighting video. That's Roomba. You know Roomba?
I think we had something similar in
You have to see they go inside Microsoft Robotic Studio. You just say, okay, clean. Yeah, clean. When they make it out, they took it out, it was a failure. was big failing. As soon as people realized that you can go and program Roomba, success, big success, and they doubled the price. That was a bad thing. That's Japan. In case of accidents and chemical wars, dirty bombs, you name it, fire, you have a robot go collect the bodies. Israelis have something similar, and they use it for suicide bombers. Because when you see someone that you suspect that's a suicide bomber, you don't go back, you don't go there to see, oh, is he dead, is he alive? No, you send a robot, and you can see robots doing that, using them very close to the front line. That's the lunar, it's not how it will be, the lunar lander. Pets, robot pets, have you seen robot pets? See? In Japan, they try to use robots in nursing homes. So instead of having a human grab the geezer, send him up, take him to the toilet, do this, do that, you're gonna have a robot.
I've seen that as well.
It's there. It's not using it. It's not widespread, but they have started going there. As you see, most of the things with a robot, it's programming. It's how you program, how and what you say, what to do. What's another robot? Army. That's a big game, and lots of money. How many of you do remember this one?
Or obliterate the obstacles in its path with its 6 49-inch
A robot.
There's
No humans, no remote control. You just let it on the battlefield find the way. You remember 3 years ago, Jafra competition. They put cars driven by robots, and they have to find their way in. So the first challenge was to find their way inside the urban area, and then they let them in the desert. And that was a really big thing. The competition was for 1 million, but the teams have spent a few millions to do that. All this thing, these are the sensors. And the first one was massive, now they get smaller and smaller.
To get its bearings and to decide what to avoid.
It's not easy to
crush.
you know programming. So almost all. So when you program a computer to go in line, if the line stops for a minute, the computer stops. Same problem with robots. So we need to teach the robot how to make this mistake and accept it. That's why it's difficult to make robots walk on the ground. That's another robot. That'll be a show. Okay, this little thing, it's not little. It's been created by students in the States as part of their masters. Boston Dynamics. So, okay, you got a job, you got a job. But it's been made inside the university from students, just like that. You just let it go in the battlefield, go anywhere. Go there, you can program it where to go. Doesn't die, can kill a robot, can break it, can good damage, but doesn't die. Some kids, when they saw that, they thought that was two men, one together, and they tried to. It's quite big. Americans American Army loves all this, and the reason is you don't a dead human costs so much money. I think it's 190,000 American dollars. So a robot costs its value, and the more you extend the robot, the less cost. As you see, it can go in any background. It has a sensor. But it's you hear how the noise it makes. It's a buzzing noise. That's the noise. I'm trying to find out the guy who made it. It was a guy with ponytail. No, American guy, ponytail, cowboy boots. That was the guy. Now let's make something more tasty.
Both the robots use robot hands from skews. By moving artificial muscles using air pressure, soft foods such as sushi and bamboo can be carried without losing their shape or being dropped.
空気圧制御で、空気圧を制御しておりまして、さまざまな形のものをですね、同じ制御でつまむことができます。
Okay, how many of you know what a Rubik's Cube is? How many of you managed to solve the Rubik's Cube without internet?
The stickers off and put it on the phones.
Exactly. There's a crazy guy. He took a toy. It's programming. That's Lego.
Oh, yeah.
Yeah, Lego Milestone. Hopefully next year this university is going to be teach, because if you were in John Moose and you were doing robotics a few years ago, they're going to make you do a robot with that. But now, we're going to have them here, hopefully next year. And that's off the shelf. You just take it and you program it by yourself. Who made that? A 16-year-old. Okay, no life probably, but who cares?
Doesn't mean like you can sell that. And get
1 minute, 8 seconds. And that's a robot.
No way.
That's even more funny. Okay, this is not been made by a 16-year-old. The guy bought the Lego for his daughter.
Yeah.
Yeah. So it's still a Lego. I remind you, it's not remote control. It's whatever it's inside. He's programming with using C. As you see, to make the OCR program inside the milestone. Anyway, I'm going to move it a bit faster. As soon as he makes the whole map of the Sudoku, it just goes and write the number. Another thing that we do here as well, it used to be a really big thing in other universities, is maze solver. So you have a robot, micro mice, inside the maze, and they have to find the solution. When I start getting involved with the robots, that was probably before you born, all of you, they just put a sensor, so the robot has to go all the way, touching, and make a big round come out. That was the most of it. Now, these are the speeds. These competitions, they say they're going to stop it, they won't have it this year anymore, it's finished. And the reason that they stopped the competition, the speeds are so high, you're just looking who has the speedest. It's not IT anymore, it's not thinking, it's speed. The mathematical formula to do this, it's not that complicated when you see it. To put it down, it's a bit more interesting. Here on the second year, they do the same. That's find the cheese. So you leave the robot, they have to go in the center, find the cheese, and then they have to go the way back. Quite interesting. We have a small demonstration, not that good and not that fast. So what happens? It has a sensor and it tries to find the exit. I don't. Theoretically, wherever you put it, it's going to find the exit. The truth is, we cheat with this one. In order to make the code simple and easy, we just make it and it follows left. If you make something and it's on the center, it can confuse that. When you want to program a mouse, micro mouse like this, when it goes inside here, it makes a memory map and knows that that's off limits, so it treats it like that's a wall. So the way that it works, when you take it at the end, you can know where is the dead end and where is not. And you can see the road, actually road, the fastest road. So when you put it back inside, it's easy to know exactly the way it's going to go out. All right. We have prepared a small workshop to do with this. We won't go that far going out of the maze, but to make a small workshop how to use the PIC micro. And by PIC microcontroller, it's that chip here. You can find it from that big to smaller than your small nail. If you have a remote control in your house, it's very possible to have PIC microcontroller inside. And washing machines, everything you have, and basically it's a small computer. You have a computer, you have memory, processor, has a memory, processor, input, output unit, everything in a chip. But if you want to grab one of the first 8 computers, Okay, you're gonna need this seat. Should I get completed? All right. You have to take the instructions very, very detailed. So if you have any problem, you ask me. First, you double click on the screen. You have flow code 6. 4. You have that pass. No, on the signal, when it says press OK, because I use the validation.
I'm getting there.
So what we're gonna do, the first one, we're gonna have one LED turning on and off. That's it, nothing else, just one. Make sure you pick, everybody is picking the correct thing.
I don't have the formula for it. It's under the desk. Yeah.
You can use it from there, you can call it.
I took the
But you have, when you logging in, you need to pick, make sure that you pick the
pick on the right one. Formula for
formula. Yeah, that's really important. But without this,
okay. So the
okay, you need press the flag. You press the flag. Yeah.
oh yeah.
Yeah. Okay. That's
Okay.
That's and then from the left.
Okay.
You have the tools on the left. You need to check the flag, sorry. The check of flag, so you can use the careful with the delay, because it's milliseconds or seconds. You're doing the second.
Am I supposed to do the second one?
You did the first one.
Yeah,
Yeah,
it looks
so
okay as
you
well.
do the second. You see the difference of the second? You can understand it because it's
Yeah.
the binary. So when you program again, you want to stack a lot of things inside with the limitation of memory. You don't use the macro. You just go and say output. I think it's output 4 point something, and then you say 255. That's quite useful because sometimes on them it's easy to program them on assembly. It's kind of pain, but it's faster, way faster. So you know what to do now. Try to do this one now.
Okay. Well, we do have the.
You remember Night Rider?
Yeah.
That's Night Rider.
Going from 1 to. Okay.
So when you do 2, try to do the Night Rider.
No problem, they grow up.
They don't have the software, haven't installed software. Take this one.
This one? Cheers.
Okay?
Yeah. I'm thinking I might be going the right way. I was thinking of creating I don't know what you can do in this example, but creating a variable that counts. I don't know. Is that the way that you
Yeah.
do it? Okay.
The code is up there, half of the code. You can put it all, but it won't be funny. So, what happened? You set up a variable,
Yeah.
and then you set the time,
Uh-huh.
and then you give the first value.
What? Press OK.
No, that's
Yeah, because you're running the LED on and off.
and then you put the first loop, and the loops, you have one big loop,
Yeah.
right, to it again and again. Then you have the first loop, you give the value, and then you increase the value by 1 to make the next LDO.
I actually could just do it by 1.
By 1, then there's 2 LEDs, then you have binary counting. So it's 1, 0, 1, 0, 1, 1.
Right. You have to.
So you need to have 1. That's the
Very
trick.
good time.
That's the trick. That's the tricky thing. That's nice. You can remove.
Trying to figure out how you define the value.
You put the value in the output. Now you do that more directly before. So you put an output, the value says 0. Change the value, put something else.
How do you define the value of the variable? That one.
Yeah. Double tick. Variable. What the value? You add it.
I've got one in.
Oh, yeah. So you can try and put a different value, or you can try and do a line like that.
I can stand next to me. Yeah. Touch it, go faster. What is this? Is that magnet? Is that a hard drive? Yeah, you don't say that. Can I eject it? Take it out.
It might not roll to you.
Oh, what am I doing? Oh no.
Sometimes how much you lose or you just like
It's just the end task on Explorer. I can't really look in there. Oh, I'll just walk through stuff in there. It's okay.
you try to do that right away.
I was.
You got just having loads of different ways of lights, like different short marks and that like
She counts it.
So think you have a washing machine.
oh yeah, I know.
How is this program a washing machine now? With this
In
one.
terms of
You say, okay, I want you now to turn left, turn right, turn left, turn right, spin fast, take water. That's just same thing. You have car. It's unbelievable how many microcontrollers they have. Because it's cheaper to have, instead of having cables running around, you have 2 power cables, 1 communication line, and that's it. Airplane, oh, that's the amount of microcontrollers, it's huge. But you have 3 different, on each sensor you have 3 different microcontrollers, and they can control everything. Stuck.
yeah.
See, I was thinking about those different lights. And then just have one big value, and then one big value again and then that's going to be like too stupid. What's this thing?
Was that? Create a variable, make it a counter, and then just make that counter.
Difference is for
Right, so it's it. But I have to
before
go to
you were
my second.
giving a value to an LED to the macro. Now you give
It's
the
good,
value
though.
to the whole value.
I always wondered how they actually wrote.
It's
Well,
8
yeah, I always wondered how they wrote codes on
You
microchips.
have the decimal, it's easy to people 255.
I always thought they just sat there with like some sort of command line. Command line. What's it called? Like editor.
Yeah.
It's kind of
Is it the light? What do you? Oh, yeah, go ahead.
It's dead. But I've got to go to my second lecture, unfortunately.
Oh.
Sorry.
Sorry.
Well, what time does this go on to?
Yeah. You're gonna think about an hour.
Okay.
An hour.
Where is actually tail end? Yeah, I think the hard drive's lost. It won't find the hard drive.
You want to move on to the third one?
Did you fly up some new
Hey, it was in.
some new fly out? Yeah.
I'm going to go learn about the use of system gratifications by social networking.
You want to see? It's on. Let's move on the other one, and we can stay playing here. That's good.
I'm trying to trust the line rider. I know one of them years. I just don't know
Yeah,
how to
that's-
execute it.
I've done it once, and then I'm stuck.
It's that variable. You need to edit that variable automatically, but I don't know.
It's easy. You know it.
Create a loop that just.
Well, how do you edit that one variable though from that loop?
Okay, first of all, what do you want to do?
Yeah, I'd say this one here has to go incrementally up and then go down.
That now has to go down, can go higher, but that's a wrong number.
So I'd say you have to start off with 1 because it's got to go
Okay, you start from 1, and then what do you need? Which number do you need this one?
1.
No, after 1.
2.
No.
On my right, it does it. Does every top go on?
Actually, yes, you need to do how it goes. This is the decimal, let's say, into the 3, okay? So 0, 1, 0, 0, 1, 0, 1, 0. Hello? Yeah, of course.
I won't be around.
All right, thanks.
I
Thanks. Yeah, so the next one goes like this, and then goes.
Which is what they actually used to do it.
So you need this one, and this one.
I use more
Big, yeah.
That's pretty.
So this one, and this one. So this 1, 2, 3, 4. So that's
Anyway,
0 on the power of 0. Next
in
one
terms
is 0 on
of
the power of 1. The third one is 0 on the power of 2. So
storyboard is
multiply by 2.
I'll redo it now.
So the thing is, I don't know if the hash will actually have that variable.
So can you put it
You said it already. So when you just go there.
So one of the main differences is you can't do storyboard.
You said it right away.
It's in a regular civil project.
Yeah, but it's not going to work as like movies and states and stuff. That as a storyboarding for other schools like well. So it's very
You remember why I said because that's how I'm
Still
doing it.
use it, yeah.
and
And then you say A,
it's just a case that you can't actually use
A, and then you say times 2 or plus 8.
software like drag and drop or whatever.
Anyway.
What's my plot? Yeah.
Thanks, Nico.
Alright, thanks for coming.
No worries.
That's how you start. You said the first
Don't
one.
you have to find the variable A as a number first though?
Yeah, you have to set it as no, you have to set it as a number first. So,
And then in this one here, you change the number, the parameter to A.
yeah, you
That
have,
takes that value.
you have this, you start from here, okay? And then you have a loop all together. Then you have, this is plus, this is minus, or multiplication, this is division. And so, but you want to do it later, so you can move on the third one. Hey. He's cheating. He's doing that for life.
I am a robot.
Yeah, good. So you need to point it out.
The thing that was me was as an officer for variable because it was like the parameters are number 2.
If it doesn't work, it might be the computer, some of the USBs are using this
That's what got me the first time, because I was trying to just setting all separate.
Well, yeah, it's actually like 16 times.
Yeah. I was trying to tease the it, and I said, about 3 minutes.
That's the second view I did. Yeah. Okay, you take it from here, you go to the table.
Oh no.
You put on the table and then you press this button.
This one?
Yeah. what happens, because the batteries are weird, kind of weird. What you program it now? You go forward and back. That's your program. The two variables you put, the one is speed,
Yeah.
and the other variable of the time is how long. So it's gonna start working until the time passes, and then it's gonna do something else.
Okay.
So you know how to work it now.
Yeah.
So you know how to program it now.
Yeah, yeah.
All right.
That means forward. Yeah.
These three keys is the keys there. You know what?
But if you did this,
When you go,
when
you program it, when you pass up, make it all the lights flashing.
Because this one says download the
All right. Just connect it. Yeah, connected. Alright, get it on. You said whatever it's inside the body. This one. This one. Second rule of IT, come on. I'm gonna tell Brian. I didn't know this was. Yes, play. No, let's see.
Why don't we go sideways when it's supposed to go on? And
Basically, that's why you want
the, yeah, the way the motors are set up, I'm more power, the other one motor.
LEDs on. Right,
Need a robot.
Yeah, go straight.
Oh, you say you need a robot?
No, you can.
That's right, I think it's one.
Yeah.
I was just
Probably
set.
still on it.
This is the house, yeah, motor to that.
No?
Right.
I'm completely up for you. Some I know what I'm on. Yeah. So basically, what's the reason for the lesson? It's more direct programming to the programming the output, because that's
How's it start?
Take the wire up.
You just take it off the phone.
Yeah.
yeah,
And then just put it on the desk and press it on the top.
So you make it faster, like, and you don't the number flow. You want to go and do. You get it?
Yep.
You need to reset it. No, don't, sorry. Switch it off, because now it goes at the end.
So it's
So
a
that
statement.
doesn't go again from the beginning. That's continuously programmed. It's not. You get classes now.
Yeah, there's no while in there. There's no while in the before. And have you got that pen? Thank you, it's just there, so I might do scroll.
So that's the idea. All right. If you want, move on the fourth one.
Yeah, go for it.
Try the spin round.
Okay, what's happened? We have battery problem. So just Give it to me for a moment. That's really nice, but in order to make it even walk, if you want to program it to walk, it's quite difficult. Also, you need to download the program again. No, yeah,
It's not goes to the side.
yeah, what happened? Because these motors are just ordinary motors, they are not like them. These are stepping motors. So just send power, current on the motors, and one of the motors takes a little less power, just a little bit. So that goes like this. When you make a robot, usually using sensors or stepper motors, so you know exactly where it goes, you correct it. So if you have a normal robot, it wouldn't go that. When you say straight, it goes straight, it has to go straight. Yeah. Are you doing all right? See, running the simulation, and you see the movement. You don't see it.
Yeah.
Put them right.
Turn along by
Connect it first. Or connect it whatever. Turn it on. Reset it. And that's it. Download the program.
Oh yeah, done that.
Yeah. You have to download the program.
And make sounds.
That's it. Take it off. Go to the table. And press the button. So, no, grab the top, this one, yeah. That's what we've done now. Moving to number 4. Do it more.
and business interact with
So
buses.
where's getting
But how aside from
two separate ones in parallel?
asked NAB, Google's number
And like to do this night driving as it moves.
No, because it's sequential. So when it's sequential, you have to do one part at a time.
Yeah. So you can get it to move and do a bit and move and do a bit.
Actually, there's a way. You add another class. So like,